Hello guys and girl, in this video I will tell you about chemistry as a science. Chemistry is the scientific study of the properties and behavior of matter. It is a nature science that covers the elements that make up matter to the compounds composed of atoms, molecules and ions. Their composition, structure, properties, behavior, and the changes they undergo during a reaction with other substances. In the scope of its subject, chemistry occupies an intermediate position between physics and biology. It is sometimes called the central science because it provides a foundation for understanding both basic and applied scientific disciplines and fundamental level. For example, chemistry explains aspects of plant growth, botany, the formation of ignitions, rocks, geology, how atmospheric ozone is formed, and how environmental pollutants are degraded, ecology, the properties of the soil on the moon, cosmochemistry, how medications work, pharmacology, and how to collect DNA evidence at a crime scene forensics. Chemistry addresses topics such as how atoms and molecules interact via chemical bonds to form new chemical compounds. There are two types of chemical bonds. First, primary chemical bonds, e.g., covalent bonds in which atoms share one or more electrons. Ionic bonds, in which an atom donates one or more electrons to another atom to produce ions. Metallic bonds and secondary chemical bonds, e.g., hydrogen bonds, van der Waals force bonds, ion-ion interaction, ion-dipole interaction. Etymology. The word chemistry comes from a modification of the word alchemy, which referred to an earlier set of practices that encompassed elements of chemistry, metallurgy, philosophy, astrology, astronomy, mysticism, and medicine. Alchemy is often seen as linked to the quest to turn lead or other base metals into gold, so alchemists were also interested in many of the questions of modern chemistry. The modern word alchemy in turn is derived from the Arabic word al. This may have Egyptian origins. Science alchemy is derived from the ancient Greek, which is in turn derived from the word Kemet, which is the ancient name of Egypt in the Egyptian language. Alternative may derive from cast together. Modern principles. The current model of atomic structure is the quantum mechanical model. Traditional chemistry starts with the study of elementary particles, atoms, molecules, substances, metals, crystals, and other aggregates of matter. Matter can be studied in solid, liquid, gas, and plasma states in isolation or in combination. The interactions, reactions, and transformations that are studied in chemistry are usually the result of interactions between atoms leading to rearrangements of the chemical bonds which hold atoms together. Such behaviors are studied in a chemistry laboratory. The chemistry laboratory stereotypically uses various forms of laboratory glassware. However, glassware is not central to chemistry, and a great deal of experimental chemistry is done without it. A chemical reaction is a transformation of some substances into one or more different substances. The basis of such a chemical transformation is the rearrangement of electrons in the chemical bonds between atoms. It can be symbolically depicted throughout a chemical equation, which usually involves atoms as subjects. The number of atoms on the left and the right in the equation for a chemical transformation is equal. When the number of atoms on either side is unequal, the transformation is referred to as a nonlinear reaction or radioactive decay. The type of chemical reactions a substance may undergo and the energy changes that may accompany it are constrained by certain basic rules known as chemical laws. Energy and entropy considerations are invariably important in almost all chemical studies. Chemical substances are classified in terms of their structure, phase, as well as their chemical compositions. They can be analyzed using the tools of chemical analysis, e.g., spectroscopy and chromatography. Scientists engaged in chemical research are known as chemists. Most chemists specialize in one or more sub-disciplines. Several concepts are essential for the study of chemistry. Some of them are: matter. In chemistry, matter is defined as anything that has rest, mass, and volume. It takes up space and is made up of particles. The particles that make up matter have rest mass as well. Not all particles have rest mass, such as the photon. Matter can be a pure chemical substance or a mixture of substances. Atom. The atom is the basic unit of chemistry. It consists of a dense core called the atomic nucleus, surrounded by a space occupied by an electron cloud. The nucleus is made up of positive charged protons and uncharged neutrons, together called nucleons, while the electron cloud consists of negative charged electrons which orbit the nucleus. In a natural atom, the negative charged electrons balance out the positive charge of the protons. The nucleus is dense. The mass of a neutron is approximately 1.8 times that of an electron, yet the radius of an atom is about 10 point times that of its nucleus. The atom is also the smallest entity that can be envisaged to retain the chemical properties of the element, such as electronegative ionization for potential, preferred oxidation states, coordination number, and preferred types of bonds to form. Element. A chemical element is a pure substance which is composed of a single type of atom characterized by its particular number of protons in the nuclei of its atoms. Now, as the atomic number and represented by the symbol Z. The mass number is the sum of the number of protons and neutrons in a nucleus. Although all the nuclei of all atoms belonging to one element will have the same atomic number, they may not necessarily have the same mass number. Atoms of an element which have different mass numbers are known as isotopes. For example, all atoms with 6 protons in their nucleus are atoms of the chemical element carbon, but atoms of carbon may have mass numbers of 12 or 13. The standard presentation of the chemical elements is in their periodic table, which orders elements by atomic number. The periodic table is arranged in groups or columns and periods on rows. The periodic table is useful in identifying periodic trends. Compound. A compound is a pure chemical substance composed of more than one element. The properties of a compound bear little similarity to those of its elements. The standard nomenclature of compounds is set by the International Union of Pure and Applied Chemistry. Organic compounds are named according to the organic nomenclature system. The names of inorganic compounds are graded according to the inorganic nomenclature system. When a compound has more than one compound, then they are divided into two classes, the electropositive and the electronegative components. In addition, the chemical and abstract service has devised a method to index chemical substances. In this scheme, each chemical substance is identifiable by a number known as its gas registry number. Molecule. A molecule is the smallest indivisible portion of a pure chemical substance that has its unquiet set of chemical properties, that is, its potential to undergo a contained set of chemical reactions with other substances. However, this definition only works well for substances that are composite or molecules, which is not true of many substances. Molecules are typically a set of atoms bound together by covalent bonds. such that the structure is electrically neutral and all valence electrons are paired with other electrons either in bonds or in lone pairs. Those molecules exist as electrically neutral units, unlike ions. When this rule is broken, giving the molecule a charge, the result is sometimes named a molecule ion or a polyatomic ion. However, the discrete and separate nature of the molecular concept usually requires that molecular ions be present only in well-separated form, such as a directed beam in a vacuum in a mass spectrometer. Charged polyatomic collections resident in solids, for example common sulfate or nitrate ions, are generally not considered molecules in chemistry. Some molecules contain one or more unpaired electrons creating radicals. Most radicals are comparatively reactive, but some, such as nitric oxide, NO, can be stable. The inert or noble gas elements helium, neon, carbon, krypton, xenon, and radon are composed of lone atoms as their smallest discrete unit, but the order isolated chemical elements consist of either molecules or networks of atoms bonded to each other in some way. Identifiable molecules compose familiar substances such as water, air, and many organic compounds like alcohol, sugar, gasoline, and the various pharmaceuticals. However, not all substance or chemical compounds consist of discrete molecules, and indeed most of the solid substances that make up the solid crust, mantle, and core of the Earth are chemical compounds without molecules. Those other types of substance, such as ionic compounds and network solids, are organized in such a way as to lack the extent of identifiable molecules. Instead, their substances are disguised in terms of formula units or unit scales. As the smallest repeating structure within the substance, examples of such substances are mineral salts, such as table salt, solids like carbon and diamond metals, and familiar silicate and silicate minerals such as quartz and granite. One of the main characteristics of a molecule is its geometry, often called its structure, while the structure of the atomic, triatomic, or tetraatomic molecules may be trivial, linear, angular, pyramidal, etc. The structure of polyatomic molecules that are constituted of more than 6 atoms of several elements can be crucial for its chemical nature. Substance and mixture. A chemical substance is a kind of matter with a definite composition and set of properties. A collection of substances is called a mixture. Examples of mixture are air and alloys, mole and amount of substance. The mole is a unit of measurement that denotes an amount of substance, also called chemical amount. One mole is definitely to contain exactly 6.22 particles, where the number of particles per mole is known as the Avogadro constant. Molar concentration is the amount of a particular substance per volume of solution and is commonly reported in mole phase. In addition to the specific chemistry proportions that distinguish different chemical classifications, chemicals can exist in several phases. For the most part, the chemical classifications are independent of those bulk phrases. Classifications, however, some more exotic phrases phases are incompatible with the contained chemical properties. A phase is a set of states of a chemical system that have similar bulk structure properties over a range of conditions such as pressure or temperature. Physical properties such as density and refractive index and to fall within values characteristic of the phase. The phase of matter is defined by the phase transition, which is when energy put into or taken out of the system goes into rearranging the structure of the system instead of changing the bulk conditions. Some think the distinction between phases can be continuous instead of having a discrete boundary. In this case, the matter is considered to be in supercritical stage. When three states meet based on the conditions, it is known as a triple point, and since this is invariant, it is a convenient way to define a set of conditions. The most familiar examples of phrases are solids, liquids, and gases. Many substances exhibit multiple solid phases. For example, there are those phases of solid iron, alpha, gamma, and delta, that vary based on temperature and pressure. A principal difference between solid phases is the crystal structure or arrangement of the atoms. Another phase commonly encountered in the study of chemistry is the aqueous phase, which is the state of substance dissolved in aqueous solution. Less familiar phases include plasmas, both instant condensates and fermionic condensates, and the paramagnetic and ferromagnetic phases of magnetic materials. While most familiar phases deal with three-dimensional systems, it is also possible to define analogs in dimensional systems, which has received attention for its relevance to systems in biology. Bonding. Atoms sticking together in molecules or crystals are said to be bonded with one another. A chemical bond may be visualized as the multiple balance between the positive charge in the nuclei and the negative charges oscillating about them. More than simple attraction and repulsion, the energies and distributions characterize the availability of for an electron to bond to another atom. The chemical bond can be a covalent bond, an ionic bond, a hydrogen bond, or just because of van der Waals force. Each of those kinds of bonds is ascribed to some potential. Those potentials create the interactions which hold atoms together in molecules or crystals. In many simple compounds, valence bond theory, the valence shell electron pair repulsion model, and the concept of oxidation number can be used to explain molecular structure and composition. An ionic bond is formed when a metal loses on one or more of its electrons, becoming a positively charged cation, and the electrons are then gained by the non-metal atom, becoming a negatively charged anion. The two oppositely charged ions attract one another, and the ionic bond is the electrostatic force of attraction between them. For example, sodium natrium, a metal, loses one electron to become an Natrium plus cation, while chlorine, a non-metal, gains this electron to become chlor-. The ions are held together due to electrostatic attraction, and that compound sodium chloride or common table salt is formed. That is all. Thank you for watching.